Here is another example based on the Thevenin theorem. Here also we have dependent source. So the question he's asking about, find the Thevenin equivalent circuit across AB terminals. So as I mentioned, there are 4 important steps to solve this example. So step 1, we need to eliminate the resistor or any element, which is where we need to find the voltage or current. In this case, we do not have step 1 because he already gave us the open terminals. Okay, so we don't need to eliminate any element here. All we need to do is convert this circuit into a voltage source, which is Thevenin, in series with resistance, which is Thevenin. That's all we need to do. So I'm going to move to step 2 right away. So step 2, our goal is find the VAB. So VAB is voltage between the AB terminals right there. So here VAB equal to VA minus VB, which equal to VA because I'm taking VB as a ground. So that is Thevenin. That's what I'm finding. So here I have a current dependent current source. So I need to find how much current this is supplying. So I need to find the I0. So I0 is right here flowing through this branch. So that value I can easily find since there is only one voltage source and one resistor. So basically I0 equal to 12 divided by 3K, that is 4 milliampere. So the current passing through this is 4 milliampere. So here is the question most of you guys might have. Is there any current passing through this branch right here? I would say no current is going to pass through it because the 4 milliampere, supposed to say 4 milliampere is leaving this positive terminal. So there must be 4 milliampere coming back to this negative terminal. This battery always expects that if X amount of current is leaving, the same X amount of current is coming in. But what is the difference here? Here probably these electrons will have lots of energy. When they reach here, the electrons will not have any energy. That is the difference. So the number of electrons are going to be the same, but the amount of energy they have is that's the difference. Now here the current passing through this branch is always 0. That's one of the important question I want to answer. That is a good question though. Okay. Once we find I0, the current supplied by the source is 20 times 4 milliampere. So which is 20 times 4 milliampere, that is approximately 80. Okay, now to find out the voltage, so current is entering from here to this, so VB voltage must be higher than the VA, but I know VB equal to 0 volts, so VBA equal to 160 volt, VAB equal to negative 160, which will give me VA equal to negative 160 volts, or VBA equal to VB minus VA, VB minus VA. So I know VB equal to 0, I don't know VA, but at the same time VBA equal to 160 volt. So VA equal to negative 160. So VA equal to negative 160. That is our Thevenin. Now step 3, I'm going to find Thevenin. Thevenin is nothing but the resistance between the AB terminals. So as I mentioned, we always replace all independent sources with their internal resistance. If it is a voltage source, replace it with short circuit. If it is a current source, replace it with open circuit. And there is a dependent source, we're going to apply a 1 ampere source. It could be a 1 volt or 100 volt or 100 ampere, any number you can take. But I always prefer to take 1 ampere source because it makes my calculations a little bit easier. Okay, always take 1 ampere source between AB terminals to find the resistance between AB terminals. Replace all independent sources with their internal resistance. So here I'm replacing the voltage source with short circuit, and since I have a dependent source, I'm connecting a 1 ampere source. So here my RAB is nothing but VAB over 1 ampere. Now here, since there is no voltage source, my I0 equal to 0, I can clearly tell them, and the current passing through this branch is 0. Until unless we have connection there, if we have connection here, then yes, some amount of current is going to go through this, say Ix, but in this case, since there is no source, no current can pass through it. But say for example, if you have a source right there, definitely current is going to divide, the same Ix is going to come back here. Since we do not have anything here, nothing is going to go through it. Okay, now I0 equal to 0, since there is no source in the loop. VAB equal to, so this current is going to be 0 ampere. So whatever this current is going to come, that current is going to go through 2 kilo ohm. So VAB equal to 2 kilovolt, and RAB equal to VAB over 1, which is 2 kilo ohm. Okay. Now step 4, my Thevenin equal to minus 160 and Thevenin equal to 2 kilo ohm. I can write this as, I can change the polarity by changing the direction. So I can change this as 160 volt, Thevenin 2 kilo ohm, and this is A and this is B. Okay, so this is my example based on second example based on the dependent source, solving for Thevenin theorem. I'll stop this video here. Next video I'm going to solve an example based on the Norton theorem. Thank you.